Hi, my name is Raswan. This is going to be a little presentation of my project russchords. I would like to cover in a couple slides what is this about, what is the idea, what are some of the features, and then I'll go through some of the technical details, what technologies I've been using, what's the architecture. So let's begin. Inspiration. I've been music team leader for a while, and I had a problem. I had a problem with um, song screenshots. They flooded across my gallery, across chats with my friends. So I had to do something with it. So here comes russchords. It's a cloud native app that developed to help church musicians to do their job. It provides with some useful tools and features. You can see screenshots of mobile, and you can check it out at trustcourts.app. So I'll cover three main concepts of the application in this slide. Um, First of all, database. The application doesn't have its own database of the songs. All of the songs you'll be able to find, search, or import. It's a database of holychords.pro. They did an incredible job. They have huge database of Christian songs, and also you can upload your own songs using Chord Pro format. Next thing is song ownership. What's cool about Trust Chords? You can, when you import a song, you obtain a copy of it. So you can do any changes, you can edit lyrics, or you can edit chords. Also, I've added some useful tools for more powerful editing. And the last thing, I had requirements so I could easily share with other people with some songs. And when I edit these songs, these people also get latest updates. So it's done using playlists. You can just create playlist with some set of songs, and you just share with playlist link with anyone, and anyone can get latest updates if you do some changes. So something like this. And it's very simple, yes, but it's very useful, and it helps me to do not look like this guy on this slide. All right, here goes the fun part. Um, you can see here the list of technologies I've been using, and I'll cover each of them in a couple slides. So let's start with cloud. Here is architecture of my application. Do not ask how much time I spent to create this diagram. So let's start with frontend. It's Next.js application, and it's deployed to S3 bucket, and then it distributes via CloudFront. Um, so when client using Next.js application, um, it does requests to our backend service. So what happens here? Of course, it goes through Route 53 DNS service, and then of course it's supposed to be application load balancer, but in my case it was a little out of budget, so I decided on just a simple EC2 instance, and it runs two Docker containers. It's Nginx reverse proxy and Jenkins. So in this case, when a frontend does request to backend service, Nginx reverse proxy just translates these requests to ECS Fargate cluster with our backend service. And then backend service works with RDS database, or it gets some data from Elastic DB table. Jenkins. Jenkins um, listens to GitHub repository, and when there are some updates, it runs whether backend job, front end, or Lambda. I use the cheapest EC2 instance, so it's unable to build the backend on the EC2 instance. So I use AWS code build, and then Jenkins just put this image to container registry, and then it goes to ECS cluster. What else? Lambda. So Lambda parses holychords.pro website to get songs, and then it puts to DynamoDB table. So backend can take from this table these songs. Yeah, pretty much it. Oh, Ansible. I used Ansible to configure EC2 instance. Yeah. So here is all the AWS services I've been using. Honestly, I had a goal. I wanted to make it under $20, but it's 35. Yeah, you can actually check out AWS console. I have this user guest with this password. I cannot guarantee that it will work forever. I'm planning to move the whole thing to Kubernetes cluster, but check it out. Maybe it will work. All right. Yeah, and I wanted to cover a little Terraform. Again, there is GitHub repo. If you care enough, you can take a look at the code. Here is 3 command of the Terraform directory. So in a couple of words, what is happening here? I did my best to make decoupled infrastructure, and I have 3 separate states: one for DNS, one for container registry, and one for environment. I did development and production, modules, templates, and stuff. All right. Next slide. Yeah, Lambda. You can see here, it is not code of the Lambda itself. It's just pseudocode, explains what it does. So in a couple of words, it just, yeah. Actually, I'll show you. So, for example, we have a song here, right? One of the way how you can obtain this song, you just, in the link, you change wholly to Rus, and it triggers API gateway, and it redirects to the website, to my russchords app, and then you can fork it, and then you can manipulate, add to some services, playlists, and so on. Yeah, or you can use just a search on the russchords.app. So the reason why I had to use DynamoDB is sometimes it takes like 5 to 10 seconds to parse the song, and when you it makes sense to just cache these things, you know. All right. So next block, Jenkins, Ansible, and Nginx. I'll read the stuff on the slides. Ansible configures EC2 instance, ensuring necessary configurations to run Jenkins and Nginx in Docker containers. This reduces manual errors and make it possible to launch the whole infrastructure in 2 commands. Yeah, it's really, I can launch the whole thing just with 2 commands: Terraform apply and the Ansible playbook site.yaml. It works if all the environment's variables are properly configured. Jenkins CI/CD pipelines. Yeah, actually, here is again. It's not the playbook itself. It just pseudocode explains what happens here. If you care enough, you can take a look or GitHub repo. Jenkins, again, the same thing, explains what it does, what jobs is there. Um, CI/CD provided by Jenkins. It starts the job when triggered. It builds front end and more heavy builds like backend sends to code build service. Then ensures it's deployed. Um, Anonymous access provided. Feel free to check. Yeah, here is Jenkins. Again, this is fine. I know. You can run some jobs. Yeah, it should work. All right. Nginx has reverse proxy. Yeah, as I mentioned before, it'll be turning out a little expensive. ECS Fargate clusters still need a single point for access for its containers with a stable IP address and TLC certificate. So Nginx used as a point of access to backend system, not a load balancer, but for my heavy load and cluster with one container enough also. It will work fine with a few containers too. As I mentioned before, yeah, it was a little out of my budget. I believe application load balancer itself would cost like $20 a month. For a pet project, it's a little high. Yeah, and the front end, honestly, nothing interesting at all. The thing I like most is my Mr. Bean loaders. Yeah, you can check them out on russchords.app. Um, for as UI library, I used Mountain. I really liked this thing. I've been working before with NTD, with Material UI, with Bootstrap, but Mountain UI I really liked. It's uh, it's very convenient. The way you can customize components is very nice, and I like the style. So also probably the only interesting part to implement, it was tricky, the engine that parses the song and can make it work like the engine that determines which are the chords in the text, and then it can change the key. Um, I tried. I spent like 2 nights trying to find a library that would work, and I tried JavaScript libraries. I tried Python libraries. Nothing worked, and then I just spent one night and I made my own engine. It was not that hard, and it was fun to do. Backend, again, nothing interesting. Super boring backend, crude. Um, Used entity framework to work with PostgreSDB, Cognito for auth, and that's it. Again, you can see here it's just tree of the project, some files, directories, controllers, just some stuff. Yeah, and if you are still here, I really appreciate it. Thank you. I hope you liked the presentation. Um, thank you very much. I hope this app can be useful for these guys. Stupid me, there is no sound. All right. Every time funny.